Welcome to Concrete Chronicles, where we break down the nitty-gritty of concrete construction and some of the risks that we see out there in real-world conditions and how we can mitigate those risks. Today we're talking bridges. Now, I want to start with the basics of how we really design those bridges and what the intention is for them. So we know concrete builds up the world around us. It's one of the most amazing building materials that we have. It's extremely versatile. So we can use it in civil work, dams, bridges, power plants, structural plants, or we can get into residential structures, commercial structures, high-rise systems, or even just drivable surfaces. We have concrete in every building, all around us. I guarantee wherever you're watching this or listening to this, you are exposed to some manner of concrete in your vicinity. So that is why concrete is so exciting, because it surrounds the world around us. And yet, there's a lot of intricacies that go into concrete construction. So when we look at concrete, we look at it as just this one structural member, but there's so many facets to concrete. It can perform in so many different manners, and it all depends on how it's mixed, how it's cured, and where it's located, and what the intention of that project is. So, in breaking down concrete construction and concrete bridges, we start with the mix. So when we build concrete, we create that mixture. We create the mixture according to the specifications, according to the code recommendations. Depending on what we're building, we're either going to mix some linemen, we're going to mix some Portland cement, we're going to mix some aggregate, and we're going to mix in water. And those ratios are going to change wherever we're building, the climate zone we're building in, and the intention, that compressive strength and tension of that concrete. That changes the mixture. So now that we have that mixture, and we have our mix proper, and we have our batch ready to go, then we pour our batch. And now we go through a curing process. That curing process is where we take those raw materials and we build that structural strength into that concrete. And there's a chemical reaction that takes place, and it cures, and now we have structural concrete, and we have that compressive strength that we're needing and that we enjoy for the structural strength of our building. And that's where we take the raw elements of the mixture, cure it properly, so that we have that structural strength, that compressive strength that we all know and love as structural concrete. A couple issues can take place along this path. We either can get the poor mixture, we have improper moisture content, it dries too quickly, or we have too much exposure to moisture, especially on site and in the field. And so when we go through the curing process, we take test cylinders and we take test samples out of the mixture to make sure that it is a proper mix and that it will cure properly. And that also gives us the confidence in that mix, in that structure, whatever we're building, that we're going to have that longevity, and that we have done the due diligence up front for that success long term. So as we go through that curing process, we get to that compressive strength, and we take those test cylinders, we cure them in a curing box, we know with confidence that that structure is now intended of what it was specified for, and it's going to perform to those intentions. Now we have raw concrete though. So it's structurally sound, but it's extremely vulnerable. When we have raw concrete exposed, it acts like a sponge. It'll soak up anything that it's exposed to. So if it's exposed to the exterior, we have acid rain, we have hard water, we have minerals, we have chemicals, we have oils, whatever it may be that it can be exposed to, whether it's on the exterior or even the interior. You're constantly cleaning with chemicals, you're exposed to acids, you're exposed to bases. Those are gonna break down your concrete. So we wanna protect that concrete in some kind of manner. We can either harden it, densify it, polish it up, put a protective coating on it, we can put a top coating on it, or we can kind of protect it fully with a membrane approach, a cladding approach, whatever it may be, wherever it's being used. But we never really leave exposed raw concrete to the elements. We always have either some additive to it to protect that concrete, and to have that concrete be a protective layer. So we really have to work with the concrete, not work against it. It's an element that we utilize on a consistent basis in construction, and we really want to work with it so that it works to our advantage rather than force against it. Because when we work against concrete, it's never going to work out for us, and it's always going to end in a catastrophic failure or a loss of life, especially when we're talking concrete construction. So we want to focus on really those minor details of getting it right the first time, and that extends the longevity of our building, that extends the longevity of our structure, extends the longevity of our bridge. So today, we're talking bridges. There's 617,000 bridges across the country. 617,000. That's a lot of bridges across the US. And it sounds like a big number, but in reality, if you're driving right now, or you're driving, from the office, or you're driving away from home, or wherever you're going today, you're gonna drive over a bridge at some point. You're either gonna drive over a culvert, some waterway, another roadway, whatever it may be, some kind of connection, an on-ramp. There's always going to be some kind of bridge, because there's that much infrastructure built up. There's that many bridges out there. 617,000 is a lot of bridges. We've put a lot of money over the years into our infrastructure in the US, and we've done a really great job of it. But we haven't done the best job of maintaining the performance of those bridges. And some corners were cut along the way. And that's kind of what we want to highlight today, so that we are aware of the situations in the real world that we're working with, rather than just living in this fantasy of that new shiny coin, of the next building that's going to come along, that next bright new bridge that's going to come along, that next hot topic that we're going to talk about. We have a lot that exists today that we want to focus on to remedy, so that we can build up for a better tomorrow with the existing materials, and a more sustainable approach in focusing on long-term solutions. So out of those 617,000 bridges, we expect a certain amount to fall down every year. Every year we're going to have some kind of bridge failure. We just expect it. Some kind of bridge is going to fall down every single year in the US, and we hope to God, we hope and pray that it's not going to be a bridge that we're driving over and there's not going to be a loss of life. But we know in 2022 we've already had bridges that have fallen down that have resulted in injury. We know that there's already been catastrophic failure bridge collapse. So we expect on average, about 126 bridges to fall down every single year. In a good year, we're going to get about 88 bridges that fall down. Other years, it's going to be close to 200 bridges that collapse. Between 88 and 200, we're going to have some kind of number of bridges that are going to collapse every single year. Every year we have bridges fall down. They don't fall down expectedly, they just collapse. And so when we dive deeper into those numbers, we've got 617,000 bridges. And a little less than half, 42%, are older than 50 years. So, when we look at buildings, and we look at the longevity of buildings, let's just say, we revamp our structures pretty much every 20-30 years. We upgrade our wall systems, our roof systems, we go in and we do remediation work. We don't always do that with our infrastructure because we kind of set and forget some of those bridge work, some of that infrastructure that takes place. So we have a little under half of our bridges that are over 50 years old. And when we look back historically, what was taking place 50 years ago? What was taking place 60 years ago, 70 years ago, 80 years ago when these bridges were installed? We had a major energy crisis. We had materials that weren't available. We had world wars and major world events that reduced the amount of materials out there. And when we look 50, 60, 70 years ago, we had differences in regulations. We had a reduction in what we have today. Some of those bridges that were built at that time period would not be built today. It would not pass what we have as our regulations in the way that they were built. And some of the bridges that we have out there are surprising that they still exist and the structure that they are. And we could get into a larger, broader discussion that yes, there were bridges that were built hundreds of years ago, that were built, before the US even existed, that are still standing today, that were built without mortar, that the Romans built, right? Of course, those are the exceptions to the rule. But we know, to our standards, to the way that we construct today, when we go back and we do inspections of our bridges, of the 617,000 bridges that we have, about 46,000 of those bridges are found to be structurally deficient. That means that we have 46,000 bridges that have some kind of structural failure out there in the real world. In today's world, in 2022, 46,000 of the 617,000 bridges that are out there are structurally deficient. Could be the bridge you're driving over this afternoon. It could be a bridge in a major city. It could be a bridge, that's never driven over, that's out in the country, that might be driven over once a year. And there's probably a mix of it all, right? Because there's so much diversity in this country, there's so many different climate zones, there's so much happening, there's extremely rural areas, and then there's major cities. There's going to be deficit bridges in all of those locations. And we hope that it's not going to be a bridge that we're driving over or we're driving under. And that's why we don't really park under bridges, right? You never know. So, those are real world numbers. That's real world conditions today, and we have money that we can allocate to that. But we aren't. We look at it and we kind of scoff at it and we say it's going to cost $542 million to upgrade all the bridges that we need to build to upgrade in Pennsylvania. And it's unfortunate that we just had a bridge collapse in Pittsburgh, but we just don't have the money to upgrade. But we do have that money if we allocate it appropriately, or we plan ahead, or we really understand some of the solutions and the innovations that are out there in the real world that we can utilize to upgrade and reduce the amount of risk that's out there. So all we're trying to do is reduce the amount of risk rather than just look at this grand number of 46,000 and say it's just impossible to fix all of them. We just can't do it. We have to start with one. We certainly can just start. And it seems like what we do is we always focus on that next new shiny thing. There's a couple $100 million, there's a couple $100 billion that are going into new infrastructure, that are going into new buildings, that are going into that new and shiny thing in all of these cities that are being built up right now. And we still have structurally deficient bridges. We still have bridges that are going to collapse this year. We're halfway through this year and we know that we're going to have probably over 50 bridges collapse by the end of the year. And we hope it's not going to be something that's catastrophic. We hope it's going to be something that falls under the radar, that doesn't hit the news. And it doesn't sound as catastrophic because we only really hear about the ones that do hit the news, that do cause injury or cause loss of life. But there have been catastrophic failures that are structurally deficient bridges historically throughout the years that have caused loss of life, that have caused hundreds if not thousands of people to die. So it is a big deal. And there are solutions out there, and we need to kind of shift that focus and focusing on those solutions and have plans in place to mitigate that risk long term. When we build today in these new shiny buildings, these new shiny bridges, and we really emphasize all of our new construction and building up our infrastructure, build for a better tomorrow. Build with longevity in mind, without corners being cut. And with my ear to the ground in the construction industry, I can tell you the last couple of years, a lot of corners have been cut. We've all gone through something in the last couple of years. And I can tell you structurally, I know of corners being cut out there in real world conditions. So if that 46,000 doesn't scare you, my guess is that number is going to go up in the future compared to what happened in this world in the last couple years. And we can all do our part to put out the right information so that we can push forward to building more sustainably, to building with longevity in mind, so that we don't have these catastrophic failures, and implementing innovative solutions to mitigate that risk. Solutions like coating so that the water doesn't degrade that concrete if we can't go back and rebuild that entire infrastructure. Coating it with something, some kind of waterproofing. Implementing structural support so that we don't have catastrophic buildings and bridges falling down. Going and doing more inspections, more detailed inspections, and having integrity in those inspections so that we don't let things just slide by and pass by. We need to raise that bar, raise the standard, and if we have, so many billion to send somewhere else outside of our country, we have that money to rebuild our infrastructure, to rebuild the bridges that we drive over every single day, to rebuild what was built and what has become our amazing country, and we have that money. We just need to allocate it to the right standards, to the right entities, and that's going to come either down to your city, to your state, and on a federal level, right? Especially when we talk bridges. So I just wanted to put it out there because I think this is a really big conversation, and I think it can be a broader conversation, but in Concrete Chronicles, it's important to understand that there are concrete failures out there. There are failures that take place, and some of it's human error. Some of there's an element of where we cut corners. Some of it's that we don't have materials. But there are also always solutions. There's always a solution. Whether you say you don't have the money, there's a solution to remedy that situation. And that's really what we need to focus as we move forward in the construction world. Thanks for joining us on Concrete Chronicles. See you guys next time.